Metals. Metals are very useful materials. Materials are the substances from which objects are made. There are many different metals. Metals are used to do different jobs. Metals are strong and tough. They do not shatter when dropped, and they do not crack easily. They can hold large weights without breaking. Metals are shiny when they are freshly cut or polished. Metals can be bent to shape them. Metals are malleable, which means they can be hammered into shape. Metals are ductile, which means that they can be drawn out into wires. Metals make a ringing sound like a bell when they are hit. The word for this is sonorous. Most metals do not melt easily. They have high melting points and high boiling points. Mercury is the only metal. Metals are good conductors of heat. When you touch them, they conduct heat energy away from the hand, so they feel cold that is liquid at room temperature. Metals are good conductors of electricity. This means that an electric current can flow through them. You need to remember that. The surface of most metals will become dull after a while. Big lumps of metal are hard to test for flexibility. Bottles and cups also make a ringing sound when they are hit, but they are not made of metal.
Section 1. What are nonmetals? Have you ever wondered what the world is made of? It is not all shiny and hard like metal. A huge part of our world is made of nonmetals. A nonmetal is an element that does not have the properties of a metal. They are a big, diverse family of materials. They are incredibly useful to us every single day. We find them in the air we breathe, we drink water even inside our own bodies. Their real power comes from variety of things, and the many different ways they can combine with other elements to make new things. They are the building blocks for so much of life and technology around us, which is pretty cool. Nonmetals are essential because they react in fascinating ways. They love to join with other elements, both metals, other nonmetals, to create compounds. These compounds have all sorts of amazing properties. For example, when the nonmetal oxygen joins with the nonmetal hydrogen, we get water. Think about that for a second. Two invisible gases combine to make the liquid that covers most of our planet. This ability to form new substances is what makes nonmetals so important. They are not just sitting there, they are actively making our world work in countless ways we often take for granted. Let's think about their variety. Some nonmetals are gases, like the nitrogen that makes up most of our air. Others are solids, carbon in a pencil, lead a diamond. This wide range of forms means they can do many different jobs. A gas can fill a space, while a solid can be used to build something. This is very different from metals, which are almost all solids at room temperature. The variety of nonmetals gives scientists and engineers a huge toolkit to create new and useful materials. Plastics fertilizers. So, while they might not get as much attention as shiny gold or strong steel, nonmetals are true superstars. They are defined by what they are not. They are not metals, but their importance comes from what they are. They are versatile. They are absolutely everywhere. Understanding nonmetals helps us understand how the world works, from the simplest breath of air to the most complex technologies we use. They are the quiet, unseen heroes of the material world, and they deserve a closer look. The dull and brittle side of things. When you picture a non-metal, don't think of something shiny. Visual sequence illustrating dull, brittle non-metal surfaces. One of the main properties of non-metals is that they usually have a dull appearance. They do not have the metallic luster that we see in a gold ring or a silver spoon. Light does not bounce off their surfaces in a bright, reflective way. Instead, their surfaces often look plain or even earthy. For example, a piece of sulfur is a powdery yellow solid. It certainly does not sparkle like a piece of polished metal. It tells us we are looking at a material that behaves very differently from a metal. This lack of shine matters because it's a hint about the material's internal structure. In metals, electrons can move around freely. This movement helps them reflect light and gives them shine. In nonmetals, the electrons are held more tightly to their atoms. They are not free to roam. As a result, light hitting a nonmetal is absorbed or scattered instead of reflected. So, when you see a lump of coal, which is mostly carbon, its dark, non-shiny surface reflects electrons held tightly by atoms. It's science, you can see. Another key property of solid nonmetals is that they are often brittle. That means when you apply force, they shatter or crack rather than bend. Think about a piece of chalk. If you try to bend it, it will just snap in half. This is the opposite of a metal like copper, which you can bend without breaking. The bonds in solid nonmetals are often rigid. They hold tight, but break completely when pushed too far. This brittleness can be useful. You wouldn't build a bridge from a brittle material. Consider the graphite in your pencil. Graphite is a form of the non-metal carbon. It's soft and brittle, so tiny layers break off and leave marks as you write. If it were strong and flexible like a metal, you couldn't write with it. So a weakness like brittleness can be a strength depending on the job. It all depends on the job we need it to do. Have you ever touched the handle of a cooking pot while it's on the stove? You can, because it's probably made of a non-metal material like plastic wood. Most non-metals are poor conductors of heat. This means heat energy does not travel through them very easily. We call materials that do this insulators. While the metal part of the pot gets very hot, heat stays in the metal, not the handle. This property is crucial for safety in the kitchen. It keeps us from getting burned. This ability to block heat is used everywhere. Think about the foam cup that holds your hot chocolate. The cup is made of plastic. It keeps the drink hot but your hands safe. The same principle works for keeping things cold. Insulation in a cooler. Insulation in a refrigerator stops outside heat from getting in and warming your food. Non-metals trap heat or keep it out, making them perfect for temperature control. Now, let's talk about electricity. Most non-metals are also poor conductors of electricity. They are electrical insulators. This is one of their most important jobs in our modern world. The plastic coating around an electrical wire is a perfect example. The plastic coating on the outside stops electricity from escaping. It keeps the current flowing where it needs to go and prevents us from getting a dangerous electric shock. This insulating property is a lifesaver. Every time you plug something in, you're trusting a non-metal to protect you. The casing of the plug. The thick cable leading to your lamp or computer. The switches on the wall are all made from non-metallic materials. Their job is to contain the power of electricity. Without these insulators, our electrical world would be far too dangerous. They create a safe barrier between us and the flow of electrons, allowing us to harness electricity for amazing things. One of the coolest things about non-metals is the different states they come in. Many of them are gases at room temperature. Take a deep breath. The air is about 78% nitrogen, 21% oxygen. Both are non-metal elements. We can't see them, but they are absolutely essential for life. Oxygen powers the chemical reactions in our cells that give us energy. Nitrogen is a key component of the proteins in DNA that make us who we are. These invisible gases are some of the most important substances on Earth. Even the non-metals that are solids show a lot of variety. They tend to have low melting points and boiling points, especially when compared to most metals. This means it doesn't take a lot of heat to make them change from a solid to a liquid, or from a liquid to a gas. For example, the non-metal sulfur is a yellow solid. It melts into a red liquid, at a temperature just a little hotter than boiling water. This property makes non-metals easier to work with in some industrial processes. Another thing to note is that non-metals are generally not as hard-wearing or strong as metals. You wouldn't use a block of solid sulfur to build a car engine or the frame of a skyscraper. Metals are known for their strength and durability, which is why we use them for those heavy-duty jobs. However, this lack of hardness is not always a bad thing. The softness of some non-metals, like the carbon used to make graphite, is exactly what makes them useful. Their properties are suited for different, less forceful tasks that are just as important in our daily lives. Let's look at some more examples. Chlorine is a powerful non-metal we use to disinfect swimming pools, drinking water, keeping us safe from harmful germs. Phosphorus is a non-metal that is a vital ingredient in fertilizers, helping farmers grow the food we eat. Then there's salt on your dinner table, which is a compound of the metal sodium and the non-metal chlorine from the air we breathe and the water we drink. Non-metals are quietly working all around us, performing jobs that are critical for our health and well-being. To put it simply, non-metals are the opposites of metals in many ways. Metals are typically shiny. They're used in heavy construction and strong structures. Metals are strong conductors of heat, and they conduct electricity. Non-metals, by contrast, are typically dull. They're often brittle, and they act as insulators. This simple comparison helps us sort the materials of our world into two big groups. One group is great for building strong structures and for conducting energy. The other group is great for insulating. They're great for creating chemical compounds and for forming the basis of life itself. They work together to make our world possible. They are two sides of the same elemental coin. In summary, non-metals are a fascinating and diverse group of elements. They're defined by properties like being dull in appearance and brittle when they are solid. They are not shiny like metals. They are fantastic insulators, meaning they are poor conductors of heat and electricity. That's a property we use to keep ourselves safe and comfortable every single day. We use them for everything from pan handles that stay cool, to the touch, to the plastic coatings on wires that prevent electric shocks. They are the unsung heroes of safety and comfort. We also learned that nonmetals come in many forms. Many are gases, like oxygen and nitrogen. The solid nonmetals tend to have low melting and boiling points, and they're not as hard-wearing as their metallic cousins. We use common nonmetals like carbon in our pencils, and sulfur in everything from matches to medicine. Their usefulness comes from this incredible variety. There is a non-metal for almost any job that doesn't require the strength or conductivity of a metal. So, take a moment and look around your home. I challenge you to be a science detective. Try to spot all the non-metals. Look for things that aren't shiny. Look for things that are made of plastic. Look for the air in the room. And check the water from your tap. You will quickly see that non-metals are absolutely everywhere. They may not always grab your attention like a gleaming piece of metal, but our lives would be impossible without them. They are simple, they are useful, and they are a fundamental part of our amazing world. Go on, see what you can find.